Okay, so we're going to review the unit circle, and we're going to review mostly 8-1D, and I'm going to do a few problems from 8-1B. I think the problems that probably gave you the most trouble. Anytime during this video, as always, I recommend if you didn't know how to do the problem, or particularly if you didn't try the problem yet, pause the video before I start the problem, try it yourself, and then go back and watch the video. I'll even give hints as to what I'm about to do. So if you still don't know how to do it, let the video run a little bit. I'll give the hint before I solve certain problems, and then pause the video after you hear the hint and try the problem again. If you don't try them yourself, it's not going to work out. Now, we're giving you a huge hint for this test. Half, roughly, about 45% of your grade will be the unit circle, which is what you see on the screen here. So I'm going to show you, I'm not going to do the whole thing, but I'm going to show you how to fill in the unit circle. Then I'll show you the completed unit circle. And although you can simply memorize all of these numbers, this method will minimize your memorization to just 4 numbers. Okay, before we start, let's remember the whole purpose of the unit circle. It's to help us figure out sine of an angle, a tangent of an angle, and cosine of an angle, right? So we learned that the sine of any angle, and we're going to use the angle measure as the variable theta. Don't forget that this is theta. Okay, that's to say theta, and theta is just a variable like x, but we often reserve it for angle measures. So sine of theta might be sine of 30 if theta was equal to 30, right? So if theta might equal 30, right, then the sine of theta would equal 1/2, for example. Okay. Let's see. So sine of theta is the y value. Remember, this is only true in the unit circle. We'll talk about a more complex version of this when we do right triangle trig. Cosine of theta is the x value at every dot, right? Every dot. So for example, this is the 30-degree dot. Okay, so the sine value of the angle is here, and the cosine is here. Okay. Okay, and then don't forget tangent is the slope. So tangent of theta is the slope. Okay, and the slope is delta y over delta x, which in this circle is just the cosine of the angle. I'm sorry, I got it backwards. Is just the y over x, right? So the is just the sine of the angle divided by the cosine of the angle, okay? So anytime somebody asks you for what the tangent is, right, tangent of theta equals this, you can just tell me what the sine of that angle is and divide it by what the cosine of the angle is. But it's easier, of course, to memorize our rules. Okay, so once we understand that, let me just move some of this stuff out of the way. Then we can go and fill in our circle. Okay, the first thing you should do when you fill in the unit circle is the angles, okay? So you start with this angle, 0 degrees, and remember we always travel counterclockwise. Now notice I'm going to skip some of the dots because I'm going to stick to a certain percentage or certain fraction of a circle, right? So this first dot is 1/3 of the way, right? If you were to travel all the way up this circle here, right? That dot is 1/3 of the way. And we know that that's a 90-degree angle, right? This is a right angle here. It's a 90-degree angle that these two axes form with each other. So if I want to know what the angle is from this first dot, right, between the radius here, that first dot, and the x-axis, right, that's the angle theta in here. Okay, that's the angle in there. That's the angle that I mark next to this dot because that's where this radius hits the dot. So we label the dots, even though the angles definitely refer to the angle that the radius forms, but we label the dots to make our lives easy, okay? So this is my 30-degree dot. And notice I've gone 1/3 of the way up the circle, so I'm not going to do anything with this dot right there, see? I'm going to go another 30 degrees, which would be another 1/3 on its way to 90. There's 2/3 of the way to 90. And then another 1/3, of course, would be 90. Now 0 and 90 you should have known already. Okay? So just imagine that the radius is a dial, and as you turn the dial, it hits different numbers. So here the dial is at 0. Here the dial is at 30. That's a 30-degree angle that the dial is forming with the x-axis. That's a 60-degree angle, and that's a 90-degree angle, which is the angle indicated there, okay? So it's a dial. You're turning a dial. And remember that this dial, or this radius, really has a radius of 1, right? It has a length of 1 everywhere, okay? And as we change the angles, it also changes the x and y values, right? So at this first 30-degree one, you get certain x and y values, but as I move it up, I get other x and y values. Now keep going this way. So another 30 degrees would be 120, another 30 degrees would be 150, and another 30 would be 180, right? So when your friends say, if you're going this way and your friends say, let's make a 180 and get out of here, you do an exact opposite direction. So you know that that has to work out. Another 30 degrees is 210, another 30 is 240, add 30 more, 270, add 30 more, 300, add 30 more, 330, and add 30 more, you get 360. So this is also, right, this is also 360. Okay, also 360. Okay, now I go back and do the 45s. I'll change color, though you don't have to, just to help you see that a little bit, okay? So now from here, I'm going to go halfway to 90, which is 45, okay? Go another half and you're at 90, but that's the same, so that didn't change. Go another 45, and that's 135, okay? And that's easy. That's 15 away from both of these, right? That's 15 and 15, okay? 180, another 45 would be 225. And then another 45 would be 270. Another 45 would be 315. Okay, and then another 45 brings you back to 360 or 0. Now, where would 390, because we often ask you this, right? Where is 390? Well, 390 is 360, right, all the way around. And then what? 30 more, because 390 is 30 more. So 30 more would bring you right back to 30, okay? It's not on the quiz, but we call that coterminal. These angles are coterminal. So 390 degrees is coterminal, meaning it ends at the same spot that 30 ends at, which is right there. So as you go around the circle, if you go 390 degrees, you end up at the same place you end up at 30. Okay, so that's coterminal angles there. You could also go negative, right? So negative goes the other direction. So if somebody said to you, let's go negative 330 degrees, you would go around this way. And you would go all the way around, almost a full circle, but not quite, to here, and you'd get here, and that's negative 330 degrees. So the sine of 30, the sine of 390, and the sine of negative, we should put a parentheses around here, negative 330 are all the same. These are coterminal. We call this coterminal. Okay, meaning that if you put them in the calculator or if you look them up in the unit circle, they're all going to be the same. They're all going to be the same. Okay? All right. Once we have the angles, and the next thing we want to do is get our x and y values. Okay? Now, the x and y values are easy because we're going to cheat a little bit, and we're going to use these numbers right here and these numbers right here. If you think on the axes, you know, right, that anything along this line has a height of 0.5. Every dot, so this dot, this dot, this dot, this dot, this dot, they all have heights of 0.5, or y values of 0.5. Although we don't care about those purple dots because they're in the middle. But if you go all the way over, to the edge, you get that one and that one, which both have a height of 0.5. 0.5, of course, because we have to do this in fraction form tomorrow, is simply 1/2. Okay? What about this? This gives me some freebies too, right? This gives me some freebies. If I go straight up here, anything along this dotted line has an x value of 1/2, right? So the x value, of course, not the y value, it's the x-axis, is 1/2. So there's some more freebies. All right? And we can go this way too. Negative 1/2 lines up with this dot and with this dot. And negative 1/2 in the x direction lines up with this dot and with this dot. And finally, the freebies at 1, 0. So what is the coordinate here? Of course, the x is 1, y is 0. Hopefully you know that from 6th grade. You can put that dot there. This dot here has an x value of 0 and a y value of 1. This dot here has an x value of negative 1 and a y value of 0. And this dot has an x value of 0 and a y value of -1. Almost done, right? Almost done. The only three left. This guy and this guy, which are the same, and these two guys, which are the same, right? And I'm not going to teach you how to do that again. You already know that. So it's radical 3 over 2, and these are radical 2 over 2, okay? And you can put them around. They're going to be negative and positive. We did all that in class, and I'll show you the completed one in a second. The last thing is the tangent, right? So the tangents are the slope. So the slope of this black line right here, this black radius, is radical 3 over 3. We proved that in class by dividing these two numbers, right? These two, that divided by that. This is a 0, and you want to put the tangents all to the right or left, right, as you go around the circle of each point. That's an easy one. That's a slope of 1. If I move this black radius to there, that's a slope of 1. Up 1 over 1, that's a slope of 1, so that tangent is 1. So we put the tangents on the outside here. You feel free to use different colors in the test. I think that'd be a great idea. This is a slope of radical 3 we proved in class, and of course this is undefined, right? We got to be really careful there. Undefined vertical lines at this point here. Now this is a negative slope because that line, right, if we move this, let me go here. If we move this, if I can grab it, this is undefined. That is a negative slope, right? So that's going to have a slope of negative radical 3. Oh, I don't want it over there, actually. I'm sorry. I want it to the left. So we're going to put it over here. Negative radical 3 to the outside of the circle is how we label this, right? This is -1, and this is negative radical 3 over 3. Once you have those tangents, all the other tangents line up going across. In other words, if I extend this black line right here, if I extend it, right, everywhere on that line has the same slope. So if this is negative radical 3, so is this, right? Negative radical 3. So just go diagonal and fill in all the rest. And when you're done, you're going to get this. Okay, so pause the video, take a look at this unit circle all filled in. Make sure all your numbers match. Make sure you remember that you know which quadrants it is. We're going to need that to answer questions later, okay? And pause the video, fix up your unit circles, make sure they look beautiful like this, and then keep going.